Good morning. We are on page 579, lesson 28. We are skipping lesson 27 and going right to page 579. We're going to work on money and time. So, our learning target is to use the four operations to solve word problems involving distance, intervals of time, liquid volumes, masses of objects, and money, including problems involving simple fractions or decimals and problems that require expressing measurements given in a larger unit in terms of a smaller unit. Represent measurement quantities using diagrams such as number lines, diagrams that feature measurement scale. Big, long words, right? More or less what they're saying is we're going to use decimals and fractions to answer questions about money and time. Does that make sense? So if we go back and look at our handy-dandy standard checker to see how many of you guys, how well we did on this, we'd go back, click this to fourth, Mr. Pathak's fourth grade, and we have use the four operations is what it started off with. Here it is, 4 MDA. Here's our standard. So, we had a whopping 0 green check marks. We had 1 clear check mark and 18 X's, which means did not get it. So only one of you kind of got it. We need a lot of help with this, don't we? So we need to work bust our butt on this. If you're on virtual and you're wondering how Miss Miracle's class did, or your Miss Miracle's class, you had the same, pretty much the same marks. 0 green, 1 clear, 17 X's. So we need to do a lot of work on this unit. This is a big unit for us. This is also a big one that we see on the M-Step, which is in a couple weeks. You will see a lot of this in the M-Step. So here we go. We'll go back to the PowerPoint and let's get this thing started. So, let's start off with the basics. How many minutes are in 1 hour? Cole? No, don't worry. Just tell me.
Oh, 60.
There are 60 minutes in 1 hour. $60 minutes in 1 hour. How many minutes are in 2 hours? Lucas? 120. How many minutes are in 3 hours? Gabe? 180. We're just adding each time. Also, what we did is we did some conversion there, right? We converted hours to minutes, right? So we're going to work a lot on stuff like this. So our first problem, who wants to read it? Read it. Alexis?
Shing does chores for 1 hour, 15 minutes on Wednesday, and 25 minutes on Thursday. Spring spends a total of 115 minutes doing chores on Wednesday, Thursday, and Friday. How many minutes does he spend doing chores on Friday?
Shing does chores for 1 hour and 15 minutes on Wednesday and 25 minutes on Thursday. Shing spends a total of 115 minutes doing chores on Wednesday, Thursday, and Friday. So, they want to know how many minutes does Shing work on Friday. So go ahead and figure it out. So we know how much you worked on Wednesday and Thursday, right? And we know that on Wednesday, Thursday, Friday, he did a total of 115. We got to figure out how much he did just on Friday. So go ahead and start working on that question. I'll give you about 4 minutes, and then we're going to work on it. We'll go from there.
Suppose you get 40.
All right. So we know that he worked how many minutes on Wednesday? Or first off, let's figure out how many minutes did he work on Wednesday, Thursday, Friday? All together, how many minutes did he work? Amelia? 115 minutes, right?
Yeah. Yeah.
So he works 115 all together, right? How many minutes did he work on Wednesday?
1 hour and 15 minutes.
Well, we gotta know how many minutes, right?
Oh,
So
yeah.
how many minutes are in an hour?
60.
And then how many additional minutes do we add to that?
15.
What's 60 plus 15?
75.
So how many minutes did he work on Wednesday?
75.
So he worked 75 on Wednesday, right? How many did he work on Thursday?
25. 25.
So Thursday he worked 25, and we don't know what Friday is, right? How can we figure out with the information they gave us how much he worked on Friday? Jacob?
So, first you add 75 and 25, which that equals 100. You don't have to, but then you can do like 115, take away, or 100.
Yeah.
And then that'll obviously equal 100. Or
8:15. So, what Jacob's saying is you combine Thursdays and Wednesdays minutes, because that'll tell you how much you worked in the first 2 days, right?
Yeah.
What's 75 plus 25?
100.
So on Wednesday and Thursday, he worked 100 minutes. And they want to know how much he worked on Friday, right? So then if we take the total of Wednesday, Thursday, Friday, 115, and subtract 100 from that, the minutes he worked on Wednesday, Thursday, that should give us the time he worked on the last day, correct?
Yeah.
115 minus 100? 15, right?
Yep. I did really bad on that.
So he worked 15 minutes.
I did it a different way.
On
and I got
Friday.
the same answer.
Now you could have just done 115 minus 75 minus 25, right? You could have done that. Is that what you did?
No, I did 1 hour equals 60 minutes. So 60 plus 25 plus 15, which equals 100. So I subtracted 115 from 100.
Then got
and
a
I got
15. Okay, that works. So she just instead of making this 75, the 1 hour 15, she did this. She made 60 for the hour, 15 for the 15 minutes there, and 25. Added them all up, got 100, and then subtracted from 115 just like Jacob did. Either way works, right? You're just adding up Wednesdays and Thursdays time, and then subtracting it to find Friday's time.
But you get the same answer then.
Yeah, it's the same thing. Any questions on that?
No.
Comments, concerns?
No.
All right. Looking back, we explained two different ways. You could add up Wednesdays and Thursdays time and subtract to find Friday's time, right? That's one of the ways. So how did you do it? You added up Wednesdays and Thursdays time and subtracted it from the total time worked on the 3 days. So we did, right? We added up Wednesdays and Thursdays time and then subtracted it from the total of the 3 days, correct? Does that make sense? Any questions on that? It's a pretty simple question, really, isn't it? Is there any issues on it at all? No, everybody understand what we did? You got it now what we did? I know you said you had issues with this beginning. You get what we do or not? We did there now? You awake? Seem a little dazed. You good? Alright. Number 2. Looking ahead. You can use a visual model such as a bar model to solve multi-step problems. You can also write and solve an equation. Suppose you want to solve the problem below. Lucy has 2 hours to do errands. She spends 15 minutes at the post office and 45 minutes at the grocery store and 40 minutes getting a haircut. How much time does Lucy have to get her car washed? So she has 120 minutes to do all these things, right?
Yeah.
She spends 15 at the post office. She spends 45 at the grocery store. And she spends 40 getting her hair cut. We got to figure out how much time does she have left to get her car washed. So we know the whole picture is 120, right? She has 120 minutes. She has 2 hours to get this all done, right? And then we can draw a little bar underneath, right? Spends 15 at the post office, 45 at the grocery store, and 40 getting her hair cut. So what are we really doing with those 3 times? What are we doing when we put them in a bar model? We're adding them all together, right? So the bar model at the right shows the information in the problem. Remember that 2 hours is the same as 120 minutes. So she adds them all together, right? How do we find out how much time she has left?
Subtract.
Subtract it from what?
Subtract 120 from 95.
You're going to do 120 minus all those times added up, right?
Yeah.
Why 120?
Because that's the total time on the dot.
That's the total time we have, right? If we find out this minus this, we'll know what that is, right? We'll know the piece that we're missing if we subtract. We'll know the difference, right? So we add them all up. 15 plus 45 is 60, right? And 60 plus 40 is 100. So then we're going to take 120 minus 100 is 20, right? So how many minutes does she have here at car wash?
I thought it was 95 minutes.
No.
20.
She has 20 minutes. So, what would be an equation for this? If we had to write the one long equation, what would the equation be?
25.
Nolan?
120 minus 15 minus 45 minus 40. What?
Yeah, you can do that. 120 minus 15 minus 45 minus 40. The only issue with this is we gotta use a lot of brackets, don't we? Because does order matter? I can't do 45 minus 40 and get 5 and then subtract it from that answer and get the answer, can I? I gotta do 120 minus 15.
You have to start with the
And then I gotta take that answer and subtract it from 45. And then I gotta take that answer and subtract it from 40. Does that make sense? That's where it gets a little tricky if we wrote it that way. So we did that would work. But you look how many I have. One parentheses for the first one, 120 minus 15. Then you have another parentheses for that answer minus 145. And then another parenthesis for the minus 40. Does that make sense, Nolan?
Yep.
Order matters there. So that does get kind of screwy, okay? And it all equals W, right? What's another way we could write this equation? Jacob?
I put them on top of each other. I did 15 plus 45. And then that was 60. I knew 40 plus, I knew 4 plus 6 was obviously 10, so then you add that 0, that's 100. I did 120 minus 100, and that got me 20.
Now let's stop there though, because we can't really put an equation up on top of each other. How can we write that as not putting on top of each other? Could I do this? 15 plus 45 plus 40, and put those around, parentheses around them, and then just do minus 120, or it'd be like this. Because 120 has to come first, right? Would that work? 15 plus 45 plus 40, and then take that away from 120. Did that get us a W?
Yeah.
Why do I have to put 120 in front? Why can't I put it in back? Chris?
Because if you put it in the back, you would have got the wrong answer.
Why? Yeah, but why?
It's
What do I always have to put first, Caden?
if you did that, you would be adding 120, right?
No, it wouldn't be adding 120 because I put subtract. Gabe?
So look at the big number first.
In subtraction, right?
Adding doesn't matter, but subtracting, you always put the big number first.
Yes.
That'd be like taking 2 away from 10.
Oh, yeah, exactly. Can I know that this answer to this addition problem is going to be smaller than 120, right?
Yeah.
How do I know that? Nolan?
Because the bar model doesn't fill up all the way.
The bar mile doesn't fill up all the way, right? 15, 45, and 40 is not past 120. So since I know that these three right here do not add up higher than 120, I know I have to put the 120 first. Does that make sense? Any questions on that? Comments, concerns? Also, we know it's smaller than 120 because she says she only has 120 minutes, right? And if she got those 3 things done, that means she must still have some time left, right? Got it? So, how much time does Lucy have time to get her car washed?
20 minutes.
And this is supposed to technically be 100, I think. But it doesn't matter. She had the 20 minutes. Any questions? Comments, concerns? How did the bar model help us use that problem?
Well, it showed us how much we had to add, and when it showed us what we had to do subtract.
Kind of. Does it compare something? What does it compare? Amelia?
It compares the time.
What time?
The time that she had altogether, the time that she had, and then the time that she used.
It compares the time. Beautiful. That's a beautiful way to say it. It compares the time you have, or you had, to the time that you have used. Does that make sense? And then we can see how much time we have left, right? If I compare the time, how much time I have to get something done, to the amount of time that I've used so far, that little gap there is going to tell us how much we have left, right? That's how the bar model works. What kind of problem is this? What kind of problems have we just done? We haven't done them in a while. Jacob?
We've done subtraction and...
Well, what do we call when we have like 2 different problems, 2 different things in the same problem? What do we call that?
Doesn't it start with an E?
No.
I don't think-
Michael?
multi-step problem.
Yeah, it's a multi-step problems, aren't they?
Yeah.
They're multi-step problems. We got to figure out what we do first and then figure out what we do next, right? It's kind of like we have to decide. You remember in 3rd grade when you guys wrote like papers or step-by-step directions? Like the most common one is how to make a peanut butter and jelly sandwich. First you get the bread out, then you get the peanut butter and jelly out, then you spread the peanut butter on one slice of bread. You put the jelly on the other side of the bread. Then you put the 2 pieces of bread together. Right? Remember? You remember writing those papers like that? The first, the next, the next, the next, then last. That's the same thing you're doing here. We got to figure out what we do first in this problem. Then what do we do next? Then what do we do next? But we have to think about what we have to do first, then next, then next, then next, right? Does that make sense?
So we're doing.
That's all writing equations are. Is us writing a map for how to do this math problem. What do we do first? Then what do we do? Then what do we do? Does that make sense? So, that's all I have. You can skip the web. Page 581 and 582 is your homework. Virtual kids, you can work on those 2 pages. We will see you tomorrow. And all that good stuff. We will continue on session 2. Have a good night.